Hello, hi. There's a video from NASA that is Deep Space Laser Test successfully concluded by NASA. NASA's Deep Space Optical Communications DSOC tech flying aboard Psyche spacecraft has been successfully demonstrated. Okay, getting into the details. Final tests of NASA's laser beam communication technology offer a promising new way to keep in touch with astronauts and spacecraft venturing into deep space, including future missions to Mars. NASA's Deep Space Optical Communications experiment, that is DSOC experiment, a technology demonstration carried aboard the Psyche mission, has completed its 65th and final test, successfully exchanging laser signals across 218 million miles, that is 351 million kilometers, surpassing all technical goals after 2 years of operations, according to a statement from the space agency. During its run, DSOC achieved 65 successful passes between Earth and Psyche as the spacecraft journeyed toward its asteroid target. The system encodes data into pulses of laser light, transforming digital information into streams of photons that can travel millions of miles. A significant shift from the radio frequencies used by NASA's Deep Space Network for decades. A high-powered uplink laser at NASA's Table Mountain facility in California helps Psyche's transceiver lock onto the signal and aim its own laser back at ground-based telescopes, where sensitive detectors capture the faint light. Advanced decoding systems then reconstruct the original data, allowing information sent from the distances comparable to Mars to be received with remarkable accuracy. Across those tests, DSOC downlinked a remarkable 13.6 terabits of data, far more than anticipated, according to the statement. Okay, you can have a look at the video now. Have a nice day. Thank you. Be curious.
Did you know NASA streamed a cat video from deep space?
We got taters!
Yeah, taters! DSOC is the Deep Space Optical Communications project. It is the first demonstration of using lasers instead of radio waves to transmit data to and from a spacecraft out to distances beyond lunar orbit.
2, 1, engine ignition.
The experiment launched in October 2023, attached to the side of NASA's Psyche spacecraft. And for its first big test, it streamed a cat video.
Why was it a cat video? Because the internet loves cats?
Future astronauts are going to need faster broadband-style connections with Earth than is currently available for navigation, health updates, streaming video, and for sending back science. This is the first step in making that possible. So how does it work? Let's zoom in with laser precision to find out. Not far from Los Angeles, JPL's Table Mountain facility plays a big role. The Optical Communications Telescope Laboratory sends a powerful laser beacon over millions of miles to Psyche.
How we've done that is by using 10 separate lasers. So we have 10 lasers that come into the enclosure. We have 10 individual channels. So you see there's kind of 10 of these collimators, those long clear cylinders. We have a few lenses that then shapes the beam to get it the right size. So by the time it gets to Psyche, millions and millions of kilometers away, it has the right shape.
Think of it as a cosmic game of catch. Table Mountain throws the pitch, Psyche catches it.
Imagine walking outside at night with a laser pointer and try to point it back at Mars. That's the kind of level of accuracy we need to achieve.
And after catching Table Mountain's signal, Psyche used its own laser to send data back to Earth, reaching a record-breaking distance of over 300 million miles. That's more than 3 times the distance between the Earth and the Sun. The Palomar Observatory uses its powerful 200-inch Hale telescope to catch Psyche's laser light, which is now extremely faint after traveling millions of miles.
So by the time the signal from the spacecraft reaches us here at Palomar, it has spread out over the Earth so that the light level is very faint. It's on the single particle of light level called photons. And the way that we send data using these photons is to encode the data in the time of arrival of laser pulses, kind of like sending Morse code using a laser pointer. The light from the telescope gets relayed down onto this optical rail here and then into this optical system, which you can see on that bench. The optics then takes the light and focuses it down onto a detector in this cryostat, which operates at a temperature just 1 degree above absolute zero. Inside this chamber, there's a detector very similar to this, with a very tiny active area. So we're taking the light from our giant telescope and coupling it down to less than a millimeter.
And tracking a moving spacecraft across the solar system is not easy, but when conditions are right, data flies.
MOS, this is GLR. We're starting to see flashes of light.
DSOC broke records almost immediately after being commissioned. We have established data rate records, giving broadband comparable data rates in the hundreds of megabits per second from Mars close range. That's the first time that anything has been done like this at distances beyond the moon.
The idea here is to slowly start having more optical communications rather than radio frequency communications to just get more data down from space. There's kind of bottlenecks now in just how much volume of data we can get down in a given amount of time from the transmitters that we have.
So we have the downlink signal from Psyche right there. That's 4 watts from 135 million miles away.
One of the things that we hope to do is enable internet around the solar system.
You can send an astronaut to Mars and have them take like a high-def video of the Martian landscape and send that down in like one pass.
A new era of space communications has begun, and it all starts with a beam of light.